Okay, hello everybody. So I think it's about that time, we're going to get rolling. My name is Joshua Lamson, and I love custom drawing with Canvas. So let's talk about why. So if you guys have not used this developer feature, I highly recommend it. If you go into settings and go into your developer options, one of the choices is to outline every single view so you can see like every view object that's actually being drawn on screen. I would try it in your apps, I would try it in other apps. It's just really fun to like see how the views are laid out in other apps. So I'll have just like days where I have this feature on, just like leave it. And one day I was just checking my email and noticed like Gmail, like one email is like one box. That's weird. So normally you'll see something like this where each individual word is its own thing. So I saw that and I was pretty excited. And it turns out they're doing this with custom views. So one of our first reasons for why we want to deal with custom drawing is we can reduce our view hierarchy load. So with that setting, you can see the number of views actually being drawn on screen. There's a lot of scenarios where each of these email items, rather than having one view for the circle and then one for the letter and then one for the title and the date, that's like at least 8 views. It's not needed. You just don't need it. It also makes a lot of things easier for more custom graphics, like charts and graphs. But a lot of times, if you want to roll one and you download a third-party library, they're massive, because it's not just the chart you need, it's like 15 other types. Another great benefit to this is views in the Android framework are designed to work with everything and anything. They're designed so that you can put your ideas into what they've built. But a lot of times, there's a bunch of stuff in there that you aren't using, you don't need to support it at all. So rather than using their versions, you can just make your own and do exactly what you need. Another big part of it, it's that magic quality. This is an email, so it's not too crazy exciting, but there's a lot of ways that you can use this to do like truly custom effects that only your app has. And last, you can reuse a bunch of stuff. Once you build one custom view for this email item, I mean, obviously we're in a big list, so you can use it over and over and use it all over your app. So where do we start? If you want to start custom drawing with a canvas, the first thing you need is a blank canvas, like literally. Everything we're going to be doing today is with android.graphics.Canvas. And this is just an interface that Android provides for drawing whatever you want into a bitmap. To actually draw things on Android, you need 4 major components. The first one is a bitmap to hold your pixels. At the end of the day, that is what Android is going to use to make what you want actually show up on screen. The next is our canvas. This is how you actually take whatever you want to draw and dictate what pixels you want to show up in your bitmap. Next, you need your thing to draw. There's a bunch of ways to do this. You can just draw shapes, rectangles, circles, paths for like more complex shapes, text. You can draw other bitmaps into your bitmaps, so the possibilities are pretty endless. And then last, you need a paint object to describe how you want those things to look. Because a word is a word, but like you want a typeface, you want font size, all those things. So how do you actually get a canvas? Well, you can just create one. Since Canvas is just a wrapper around a bitmap, you can just create a new canvas and give it an explicit bitmap. I found this is a pretty rare scenario. The only time I've used it is when we were interfacing with a printer and we needed to send it just a full bitmap with whatever we needed in it. So we used it for that case. But more often than not, one will be provided for you by Android, by the framework, whenever it's relevant and you need it. So there's a lot of popular options. The one that we'll focus on the most today is view.onDraw. When you override that method, Android will give you a canvas object for that view, and you can put whatever you want in it. ViewGroup also has a onDraw method since it is just a view. Drawable has its own draw method. We'll go into some detail about overriding that and actually gaining access to that method. There's also some, those are the big 3, but there's also some extra stuff like item decorations for Recycler View. When you make a custom one, at the end of the day, you just get onDraw with the canvas for the whole Recycler View, and you can draw whatever you want on it. And it'll also give you some information about what's currently being shown and what your Recycler View contains. So how do we get painting? once you have your canvas, in order to dictate how everything will look, you'll need to create your own paint objects. Those will not be provided for you. So every single paint is going to end up having a color. That's like basically everything is going to have that, or nothing will show up. But you can have a bunch more stuff. I find the thing that I put on most paints, the vast majority, this anti-alias flag. What that does is it ensures that everything you're drawing is smooth. What it'll do is, let's say you're drawing a circle. When you draw it, if you don't have this flag, it'll look all pixely around the edges, because we're trying to draw a curve on like a bunch of little boxes. So what this will do is, based on what you're drawing and where you're drawing it and what's behind it, it'll interpolate those colors so you get one nice smooth curve. There's a bunch of other stuff you can throw in this as well. Later we'll talk about making text paints. So you can give it anything that defines how you want your text to look, a typeface, a text size, text style like bold. When we're drawing shapes, you can give it a behavior for how you want to draw that shape, whether you want it filled in, just an outline. And you can get really fancy, and you can give it like custom shaders. I personally don't have a lot of experience with this. That could be its own talk. You can do incredible stuff with shaders. So we have our canvas, we have our paints. How do we navigate around? When you have a canvas, the top left is always going to be 0, 0. And that's something that the overall view hierarchy uses for Android as well. What's important with the canvas, though, is that it has its own coordinate system. So regardless of where on screen that canvas will be drawn, when you're drawing on a canvas, 0, 0 is the top left of that canvas, not necessarily where you are on the entire screen. So what is actually providing you the canvas doesn't so much matter. There's other scenarios where, rather than using like an X and Y coordinate, you'll be using rotational coordinates, mostly when you're drawing arcs or circles. So there's a couple things to note here. First, 0 degrees is at 3 o'clock. So if you imagine like this is a clock face, 0 degrees is going to be where 3 p.m. is. You also need a radius. So once you declare some number of degrees that you want to draw your arc or circle, you need some radius to dictate each individual point in that arc. And last, an important note, arcs are always drawn clockwise. So if you give it a starting angle and then a total number of degrees you want to draw your arc, it will always go clockwise from your starting point. So let's get started. Let's jump into an example. So the first one we're going to talk about here is a bar chart. This is a great example because it can fit into any size that you want. It can reflect a whole bunch of types of data. And there's a couple components in here that we care about. So when you're tasked with drawing a custom view, the first thing you want to do is break it into discrete chunks. So we're looking at this. You may have a more detailed comp from one of your designers or something like that. But you want to look and distinguish each individual thing that you're going to need to draw. Here we have 3 chunks. First, we're going to want to draw the dark black line on the bottom and the left for our axes. Next, we have 10 guidelines going up, so 10%, 20%, etc. And then we have our bars, the actual data that we're trying to represent. The next question you want to ask is, what dimensions are actually defined here? If you are working with a designer, they're probably going to have ideas on this. But the big question that we want to answer here is, let's say that we need to draw this in a bunch of different sizes. If the width of this changes, like what looks different? In this case, we're going to define it with 2 numbers. First, we're going to define some padding on the edge of the graph, so we have some spacing on every side there. And the other thing we're going to define is the spacing in between the bars. So what that means is, if we were to change our width, the bars are just going to fill the rest of the width after we've defined the spacing between them. So let's look at some code. So when you override view inside the constructor, the first thing you're going to want to do is initialize everything you need. Our goal here is to keep onDraw as light as possible, so everything you can do up front, you're going to want to do that. So here, the most important things that we're going to need are paints. So our first one, we're going to look at our bar paint for drawing each individual bar in our graph. So the constructor is pretty simple. There's another constructor that you can pass flags to, but we'll go over that a little later. So the 2 things we care about for this paint specifically is we want it to fill. So when we draw a big rectangle, we don't just want an outline. We want the whole thing to be filled with color. And then we're going to set our color to whatever color we want our bars to be. So next we're going to define our paint for drawing our grid, our axes. So in this case, it's going to look really familiar. We're going to make a new paint. In this case, instead of having it fill some large area, we just want to draw lines. So we're just going to have it stroke. We're going to set a color the same way we did before. And now that we want to stroke, another thing that we need to set is the stroke width. So when you're drawing a line, you're not necessarily filling an area, but that line can have variable width. So you can make it really thick if you want, if you'd rather draw lines instead of rectangles. And then we're going to do the exact same thing for the guidelines going up, and everything's going to look the same here with its own thickness and a different color. So once we have everything initialized up front, we can override on draw. So it's a pretty straightforward method. We're going to be given a canvas directly, and this is where we're going to do all of our drawing. The first thing that we're going to want to do once we actually start drawing is getting our width and height. Since we broke it down before by how big each individual component is, the space between them, etc., the first thing we need to know is how much space we actually have. So we'll start with this. The next thing we want to do is to start building the dimensions of how we want to draw our graph. In this case, we're defining some padding around the outside. It's worth noting that view groups have a padding that you can give it intrinsically. If you want to support padding for your custom view, you need to account for it here. Unlike margins, which are accounted for by the larger view group. So in this case, we're just going to set up our left, our padding distance from the left side. Our bottom will be the total height minus some padding, because remember, our bottom is going to be bigger numbers, our top is 0. Our top will just have some padding from the top, and the right will have our width minus that padding. So now that we kind of have the area that we want to draw within, we can start drawing our individual components. What's worth noting here is that when you're drawing things on Canvas, every time you draw something, it will be on top of everything you've previously drawn. So in this case, we're going to start off by drawing the axes. Everything that you end up drawing on Canvas is going to look very similar to this. You'll have your canvas, and then you'll say, draw something. In this case, we're going to give it a line. There's a couple of things we need to actually define where the line is going to be drawn. We have a start x value and a start y value, and then a end x and end y. So in this case, we want our line to start on the bottom left and go to the top left, so this will be the left side of our grid. We'll also give it a paint so it knows what that line should actually look like. That has all the colors set already. We've already set that up before, because you never want to initialize objects in OnDraw. That's a really, really important rule. So next, we're going to do the same thing, but this time we're going to start from the bottom left, and then we're going to go to the bottom right. So this will be the bottom line of our grid. So now we have our axes. Next up, we're going to draw our guidelines. So similar to setting up kind of the area that we want to draw our grid within, the next thing we're going to want to calculate is how we're actually going to place these lines. In this case, we know that we want it to be on every 10th percent. So if we take the total height of our grid, which is just going to be our bottom minus our top, and divide it by 10, that's going to be the spacing in between each individual line. So now that we know that, we can just start at the top and iterate through. So in this case, we know we want 10 lines, so we're going to iterate through this loop 10 times. For our Y position of each guideline, we're going to start at the top, which is either 0 or our padding, if they've decided they want that. And then we're going to add some number of spacings to it. So for the first one, it'll be 0, so it'll be drawn directly on the top of the grid. And then we'll move down a bit, down a bit, down a bit until we reach the bottom. So after we have that Y value calculated, similar to how we did before, we're just going to call draw line. So we're going to start on the left with that Y value and then go to the right with the same Y value, so we'll get one big horizontal line across the graph. And again, we'll give it a paint so the line actually looks like something. So the last thing we want to do is on top of our grid is we're going to draw our individual bars. So in this case, the numbers that we have defined is the spacing. The spacing will not change. Then each individual bar needs to fill that width. So we're going to do some math here to figure out how wide each bar needs to be. So first off, we're going to calculate the total amount of spacing with our entire width. We know that each bar is going to have spacing on the left and right. So the total spacing is going to be the number of bars we want to draw plus 1 times our spacing. So now we can get the individual column width by taking our right side minus the left side, which is the total width of the area we want to draw the graph in. we subtract the total spacing, and then we'll divide it by the number of columns. So now we have the width of each individual column that we want to draw. And then we need, the way we're going to draw this is we're going to start with the leftmost one and then move it over and over and over. So same like we did with the guidelines, we know we're always going to draw from left to right, and we're just adjusting the Y. Here, we know we're always going to draw a rectangle from the bottom to some top with the left and right. So we're going to start our left with the left of the grid plus some spacing, and then the right of that column will be the left plus the width of the column that we expect. So now we can start iterating over and drawing each individual bar. In this case, I just have something named data. A step that you'll need to add when you're creating this custom view is whatever data you're trying to display. I find it's really useful to, instead of trying to do all your data transformations within the view, it should all be done by the time you're actually drawing. So in this case, our data is just a bunch of floats, but if you're not dealing with that, boiling your data down to a simple number that you can do all your math with is really helpful. So in this case, the variable here for each individual column is how tall it is. So in this case, we need to calculate what Y value the top of our bar will be. So we're going to start with the top of the grid, because that's the tallest it can be. And then we're going to add our height of the grid times 1 minus our percentage. The reason we're doing the inverse here is because we know if we're showing 100%, we want the bar to be as tall as the entire graph. So in that case, 1 minus 100% is just going to be 0, so our top will just be the top of the grid. Then if we want to show an empty bar, in that case our percentage will be 0, so it's going to be the top of the grid minus the height of the grid, which means our rectangle has no height. And then every value in between is accounted for. So once we have the top of our grid, we just need to draw a rect. So this should look pretty familiar. It's going to look a lot like drawing our line, but in this case, instead of a start x and y and an end x and y, we're going to define it with a left, a top, a bottom, and a right. So in this case, we defined our left and right of our column before, so we're going to start with the left up top, and then we're going to draw it to the top we just calculated, and then the right side will be the right that we calculated before, and then the bottom is always going to be the bottom of the grid, because that's where every bar is going to start. And then like we have with every other draw call, we're going to give it a paint so it knows what it actually looks like. So after we draw each grid, here we're just going to shift over our left and right. So the left is the next column over, is just going to be the right of that column of the previous column plus some spacing, and then the right side of that column is going to be the left plus some width. So we'll iterate over every piece of data we have there, and that's what our on-draw looks like. So let's walk through that, because we just drew a lot of things. So the first thing you're always going to want to do, initialize everything up front. In this case, just a bunch of paint objects. The next thing you're going to want to do is override on-draw. Keep it light. This is the most important thing. On-draw is going to get called every single frame that Android needs to actually render. So you need on-draw to be quick enough so that you can do it in that 16 milliseconds that it takes to calculate a single frame. So you want to do as much work up front as possible. So once we've overridden on-draw, we want to iterate through it and draw every single component. In this case, we drew our axes, and then we drew our grid lines going down, and then we drew our bars from left to right. So let's talk about some extra credit here. So now that we have kind of our custom graphic defined, like we know all the numbers, we know what can and can't change, now that we have all that math figured out, we can start doing some fun stuff with it. In this case, let's say we have some button, or if you just want it to look like this when you first come into the view, we want to take those bars from empty and then animate it to their final value. So in this case, what we're going to want to do is create an animator. We can give it a duration and an interpolator, however you want your animation to look. And you can have entire talks on animation, so I won't be going too deeply into how these work. But the important part as far as custom views is you need to add an update listener to your animation. So once we actually need to animate the data, whether it's when you first get data or you want to do it on a button click, we'll just tell our animator we want to animate from 0 to 1, and we'll start the animation. That line right there, animating from a float of 0 to a float of 1, is really, really powerful. Basically, for any kind of animation where you're modifying some values that you've already determined, if you can dictate your beginning state and your end state you know when you have a value of 0, you want it to look one way. When you have a value of 1, you want it to look another. And then you just end up multiplying something by that float for every in-between case. The last bit is this animation update. So when we set our update listener, this is what's actually going to get called. There are 2 important things here. One, we need to actually update the fraction for how tall these need to be. So we'll call getAnimatedFraction here. And then the second most important thing is you have to call invalidate. This is the method that will tell your view, oh, hey, something changed, I need to be redrawn. Otherwise, onDraw won't get called again because it doesn't need to be. So now, if we go back to our onDraw, when we're dictating how tall we want our bar to be, we now have another number. So instead of just doing 1 minus whatever percentage height we're trying to draw, we can multiply that percentage by that float that's going from 0 to 1. So when the animation starts, we're, like all of our percentages will now be 0, and then at the end, we'll just be multiplying by 1, so it's the actual data that we want to show. So that's our example for drawing on a view. So the next place that you can override onDraw and start drawing your custom stuff is view groups. What's important to note about a view group is that view groups are views. Everything a view can do, a view group can do, it just also can hold children. But there is an additional step that you need to actually be able to draw those views. This is my least favorite method of all time because the name is unnecessarily confusing. So you need to call set will not draw false. So in this case, if you won't draw, it means you will. So you have to call this in order to tell whatever view group you're overriding, like, hey, I want access to the canvas, and I'll be drawing some things on top of it. So similar to view, we have onDraw. What's important to know about onDraw for a view group, though, is that it will draw before the children are drawn. So anything you do to the canvas here will happen behind our children, like these little pink bars on the left. There are also some other methods that ViewGroup will provide where you can get access to that canvas. One of the most powerful ones is dispatch draw. What this method is there for is this is where a ViewGroup will tell all of its children, okay, I'm done, you can go ahead and draw. So if you override this method, you get access to canvas in the same way that you would in onDraw, but you can also control when you call super.dispatchDraw, which will actually tell your ViewGroup to tell all the children to draw. So if you want to draw underneath, you can draw a bunch of stuff, then call super to draw the children, then after calling super, draw more stuff on the canvas. And in that case, you'll start to draw on top of all of your children. Also, in API 23, they gave you an additional onDraw method. In this case, it's onDraw foreground. This is really useful because it's used by a lot of view groups that have additional stuff to draw on top of the children. For example, scroll view. When you have the little scroll bar on the left, and you can't actually see it in this picture, which is a shame, that is where your scroll bar is being drawn. So if you are implementing a custom scroll view or you want some additional UI based on the state of the view group, you can use this to draw on top of absolutely everything. So the next object that we can start drawing with the canvas in is Drawables. Now this is likely a pretty familiar term. There's a lot of ways in Android that you can gain access to these. For example, you can bake in assets into your project. You can create custom XML drawables. And you can access all of these either with r.drawable in code or @drawable/ whatever in XML. So you've more than likely dealt with drawables before. Drawable is a really vague term, and that's kind of intentional. Drawable is just an abstraction for something that can be drawn. That sounds boring, but like that is from the docs. That is the official declaration for what this is. So the important thing that a drawable has is it has its own draw method. Similar to onDraw, dispatch draw, all of those others, it's just a method where you can gain access to a canvas to do whatever you want with it. One caveat with drawables, in addition to that draw method, the other thing that you'll need to have is bounds. When you're actually drawing a drawable onto some other canvas, you need to have those bounds to dictate where that drawable will actually show up. And we'll talk about intrinsic bounds in just a second. So if we want to override a drawable class, there's a couple methods that you'll need to define. Set bounds you don't necessarily need to overwrite, but it's really useful for figuring out how big your canvas is. It kind of replaces get width and get height that you have from the view, so that you can override that or on bounds change to get access to how big your drawable is and where it's being drawn on some other canvas. Intrinsic width and height, I mentioned this before. You can override these methods to dictate the default size for your drawable. So if you're making, let's say, like a little notification badge for a number of unread messages or something like that, you can dictate how big you want it to be by default. It's worth noting, if someone calls set bounds on your drawable, it will ignore the intrinsic width and bounds. But if they don't, that will be the default. There's also a couple methods that you have to override that Drawable dictates you have to. The first two are set alpha and set color filter. Both of these are called by the system, and any paints that you initialize in your Drawable class, both of these methods you can call directly on your paint objects. So more often than not, you can just delegate it there, so whatever you're drawing will reflect the value set here. The next one is get opacity. This is something that the Android system will look at to dictate what kind of visibility you have behind your drawable. So you're going to end up returning one of these 3 pixel format variables. The first one is opaque. This implies you're using the entire space of your drawable and nothing is visible behind it. Transparent is the opposite. That you're drawing literally nothing and everything is visible behind it. So more often than not, you're probably going to return translucent, which is somewhere in between. You're drawing over some of your bounds, but not necessarily all of it. And then the most important method, we have draw. So that's going to be really familiar. So let's look at extending one of a drawable. So in this case, we're going to go back to our Gmail example. All of these, if you have a profile picture, you can show that. But in the case that you don't, you can draw one of these. So we're just going to define it, or we're going to take the same steps that we took with view. We're going to ask 2 questions here. First, we want to break it into discrete chunks. So in this case, we know we just have a circle with a letter inside of it. And then we want to ask what dimensions are defined here. So in this case, the circle is going to be some size dictated by a radius. The text will be some size. And then we know that we want the text to be centered inside of that circle. So let's jump in. So inside our constructor for our drawable, we've just overridden the drawable class here. In this case, we know that we need some letter to draw. So we're going to save that first. Next, we know we're going to paint some stuff. So like we did before, we're going to create some paints. In this case, because we're not just drawing lines and rectangles that have no problem being drawn on a square pixel screen, in this case, we're drawing things with a lot of curves. So we'll want to use this anti-alias flag. So all of our curves will be smooth and they'll look really good. And then we know our circle will have some color. After that, we're going to create our letter paint. In this case, this is new. We haven't used a text paint yet. Most of what you can do with a text paint is very similar to a normal paint. We'll go ahead and set the anti-alias flag again so everything is drawn normally and smoothly. We're just going to set our color to white. And the 2 new things here is the text size, which is exactly what it sounds like. And then we have the text align. In this case, this alignment is a horizontal alignment. So whether you're going to be normal, which will respect your current locale, either left to right or right to left. But in this case, we know we want it to be centered. What's important to note with this text alignment is it will affect what coordinates you need to use when you're dictating where to draw your text. So if you're using normal coordinates, let's say left to right, 0 is going to be the left. But if your x-coordinate is going to be the leftmost part of your text. But in this case, we're using center. So any x-coordinates that we use to dictate where that text is drawn, that will be the center of the text that we're drawing. So one more thing we need to do here. So I mentioned that the text alignment is going to affect the x-coordinate, but the y-coordinate for drawing text is always going to be based on the baseline. So in order to center our text vertically, we'll need to do some work to figure out how big our letter actually is. Luckily, TextPaint has a really useful method for this. We have get text bounds. So based on your paint, you're going to give it the string that you care about, a beginning and end index for that string, and then a new rect. And what it will do is, based on the text size and any attributes set on your text paint, it will tell you the total space you need to draw that string with that paint. So we'll use that to get the total dimensions of our letter, and then we're just going to create a little top padding here. So rather than drawing the baseline at the top so you can't see the text, we're going to nudge it down a bit so it'll actually be centered vertical. So similar to before, we defined everything up front. So now, when we override our draw method, there's not a crazy amount to do. First off, we know that we're going to draw a circle. In this case, there's not too much to define. We know we need an x-coordinate and our y-coordinate for the center of our circle. And then that third thing is our radius. In this case, since we know we're trying to fit within some bounds, we're going to go ahead and assume we're fitting in a square area. So our radius is just going to be half of our total width. And then last, we'll give it a paint so it knows what it needs to look like. After we've drawn that circle, we're going to go ahead and draw our text. In this case, there's a couple things we need to give it. First off, we need to give it the string that we actually want to draw. We'll give it an x and y coordinate, and then our paint. So we discussed the coordinates a little bit. In this case, we want to draw, for our x-coordinate, we want to give it the center of our space because we set that center alignment. So that's what dictates where we draw in the x direction. And then for our y, we're going to take that top padding, which is half of the height of our font, and then we're going to add center y to it because we're drawing on the baseline. So we want the bottom of our text to be half the height of the text below the center. And then we'll give it our letter paint so it knows what font to use, what text size, and all that. So this is not so bad if you're drawing a really small piece of text, a little label or something like that. But this can get confusing when you want to draw large pieces of text. So how do we do that? We know that we have this. It's possible to draw any kind of text with it, but it doesn't really give us the fine-tuned controls of drawing large pieces of text. Let's say if we're drawing a paragraph, there's a couple things that we don't really have control over, such as line breaks or ellipsizing the text if it's too long to fit in some area, maximum number of lines, things like that. So in order to solve that problem, we have two great tools we can use. First is android.text.layout, and the second is android.text.spannable. So our layout, there's two types. There's a static layout and a dynamic layout. The biggest difference is whether your text is going to change. So if you're drawing static text that won't change, you want to use static layout. And then if you're using text that will constantly be changing, like in an edit text, you want to use dynamic. Let's talk about spannable string. So what spannable string will allow us to do is dictate the style of the string itself that you want to draw. Not necessarily how it's drawn in some area, but how each individual letter looks. So you can make it bold, italics, you can set style, give it color, highlighting. You can actually make like clickable links. It's very, very powerful. There is a whole talk on this tomorrow at 10 a.m. Stacy is giving it. So definitely check it out because these things are ridiculously powerful. It's also worth noting you can just use it with text view. So it's really useful when we're drawing our own text, but there are so many applications to that thing. And then static layout. So we know as opposed to controlling the text itself that we want to draw, our static layout will control where the entire text is drawn. And this will control things like break strategies, ellipsizing, how much area you actually have to draw your text within. It also provides a couple convenience methods like the get text size on the text paint that will give you some information about how your text will draw once you pass in a canvas. So do we have a canvas.draw static layout? Turns out this does not exist. So instead of that, it has its own draw method. So similar to Drawable, rather than you overriding it and implementing on draw yourself, static layout is going to do that work for you. It's going to dictate where the text is going to draw, how big it needs to be, and will draw itself on the canvas. So let's look at another example here. So this is my really simplified version of Gmail that we looked at before. So like we have with all the other examples, let's break this down. So first, let's define each individual component. The first one, we know we want to draw this icon on the left. It's just going to be a circle with an individual letter in it. This was the previous example, so we've already made a drawable for this. Next, we know we're going to have at most one line for the people we're sending the email to and from. And then we'll have a subject and a preview. And it looks like we're concatenating those. So if the subject is 2 lines, we'll just kind of append it there. So next, what dimensions are actually defined here? First, we know that the icon, the circle to our left, is going to be a set size, and there's going to be some spacing around it. We know the list of people is going to be a single line, and then we know the subject and preview will be up to 2 lines. So let's dive into some code. First thing, same as we've done before in our constructor, we want to initialize all of our dimensions, our padding, our icon size, things that dictate how big everything is. Next, we want to initialize our paints. This is everything we're going to use to actually draw that stuff onto a canvas. In this case, we'll have one for the people list and another for the email preview. So in this case, everything else before has been pretty static. We've known what we want to draw up front. So in this case, we'll need to recreate some things every time we get a new email. So first, we'll want to create a new drawable. You could also update this, so you can use one drawable and validate it and just update the letter that you're drawing. So we'll go ahead and create an icon drawable based on the whatever preview letter we want to use in that circle. And then, important step, we have to set the bounds in order for this to draw the right place on our canvas. So in this case, we know that the top left will be inset by our padding, and then our bottom and right will just be that top left plus the size of the icon. Next, we're going to need to actually create our layouts, so once we get to on draw, all the work is done. So the first thing that we'll need to define is how much width we actually have to draw that text in. So in this case, we're going to calculate that by taking the total width of our view. Then we're going to subtract the width of everything on the left, in this case 2 times the padding and the width of the icon. So now we have the left side of our text. And then from the right side, we'll subtract the padding on the other side. So now we have the width that our text can fit within. Next, this is a really nice convenience method that I found in TextUtils. We're going to use this to ellipsize our people list down to 1 line. So this is comma ellipsize. You give it a comma separated list. You give it a paint. You give it the width that you can fit within. And then these last 2 strings dictate how you want to ellipsize it. So if you have a giant list and there's +1, it'll be +1. And then you can give it a format for if there's +8, you can just shove the 8 in there. So that will give you a 1-line string that fits within that width. So last, we want to create our static layout. There's a bunch of things you can give static layout. Again, this could be its own talk. There's a lot of things you can do with this. But this is the most simple constructor. We're going to give it the text itself that we want to draw, that ellipsize from text that we made before. We're going to give it the paint that we actually want to draw with. This will have the size of the text color, all of that. We'll give it the width that we need it to fit within. We'll give it a, in this case, this is a vertical alignment. These next 2 numbers will dictate line spacing. So if you want to draw multiple lines, this will dictate how much space is in between each line. One of those numbers is a multiplication, so it'll take whatever value and multiply it by that much. The other one is addition. That addition should actually be 0, that's my fault. So in this case, we're just going to take that spacing, multiply it by 1, so not change it, and then we're going to add 1 pixel to it. This last one is whether you want to include your font padding. More often than not, you don't need to worry about this, but especially like when we're drawing that individual letter, something like this can be useful. So that is our text layout for drawing the people list. Next up, we have our preview text. In this case, we're just going to get the entire string, so we're just going to take our subject, add the entire body to it, and then that Unicode is just a long dash. Next up, we're going to create our spannable string with that text. And what this will let us do, and again, whole talk on this tomorrow at 10, you can set how you want your text to show up. In this case, we're going to add a span to make the first chunk of this text bold. So we're going to give it the span itself, which dictates what style we want to apply. We're going to give it a start and end indice. In this case, we want to start at the beginning and either the whole thing if there's no body or the length of the subject. And then this last integer will dictate how these indices work, whether you want to include your last indice or not. So now we have our string, and we're going to do a similar thing here for building our layout. We could use that same constructor before, but I wanted to take this time. This is the new way to do it with Android M and above, so 6.0. Now there's a really nice builder pattern. So we're going to start off and give it some of the things we did before, the text we want to draw, a start and end indice, and the paint. And then the width that we need to fit that text within. We're going to set our alignment for how we want that text to behave within its area. Next, we're going to give it some behavior on how we want it to ellipsize. In this case, we want it to ellipsize at the very end with a dot, dot, dot. We want that width is how much area we're going to fit within, so we're going to give it that width again. And in this case, we want to ellipsize after 2 lines. So one of the reasons that I showed the new version with the builder is that on older versions of static layout, the ellipsize option does not actually work. I won't be diving into how to do that today, but at the end I'll have a link to an example project with all of these in it, and that will have some code and some examples on how to handle that ellipsizing for multiple lines before M. So after we've set everything we care about, we'll go ahead and build our static layout and set it. So now we have everything we need to draw. So our next step, we're going to override on draw again. So we have a couple things different with this one. First, our drawable. In this case, rather than telling the canvas to draw a drawable, the drawable knows how to draw itself. So all we need to do is give it that canvas. So we're going to do that here. What's important to note, the bounds have to be set for this to draw in the right location on that canvas, which is why we did it ahead of time. So the next part that we need to handle is how to draw our layout. So when we're drawing individual shapes, like the lines and rectangles we dealt with before and the circle, we can give it coordinates for where it needs to draw on the canvas. And then for drawable, we give it the bounds to accomplish the same thing. Text layouts do not have this mechanism, so you don't have a way to tell it, to tell the layout intrinsically, I want you to draw here on any canvas I give you. So what we need to do here is rather than giving it a location to draw on the canvas, we're going to shift the canvas itself. So a good example to think about this is perhaps a 3D printer. You have the actual pen itself, the thing shooting out the ink, or the model stuff, I don't actually know what it's called. That. Then, instead of moving the output itself, you're going to move the base underneath it. So you can also think of like in shop in high school, you have the drill that you pull down. You're just going to move the wood and then stamp it. So we're going to do that here. So the first thing we want to do is we're going to translate our canvas so the from text is going to draw in the right place. So in this case, we're going to translate it with an X and Y. We know the left of the text is going to be 2 times the padding plus the size of the icon in, and then the top is going to be from the padding. So then the canvas has been translated. We can just give the canvas to the layout, and it will assume that the canvas is normal. So it'll just draw it on 0, 0. But now, instead of 0, 0 being 0, 0, 0, 0 is these numbers here. So after we draw the from layout, we haven't untranslated yet. So now we're just going to translate a bit more. So now we're not going to move left and right at all. We know the left alignment is going to be same between those 2 pieces of text. And then we're going to shift it down a bit. In this case, we're going to take the text size of the from paint, so it'll be that same height. This is accomplishing the same thing of taking the text bounds and putting it in that rect and using that height. And then we're going to add some spacing to it. So we have some space in between those 2 lines. And then, same as before, we can give the canvas to that preview layout, and it will draw itself. Now, we've messed with this canvas. It's not in the state that we got it before. So there's a very important step that you can't forget to do. Before and after you mess with your canvas, we have 2 methods. We have save and restore. What this will do is it will, it's kind of like database transactions. It will remember the initial state of the canvas, and then when you call restore, it will back up 1 step. So this will let us do whatever we want to the canvas to draw the text in the right place, and then we call restore, so anything else that is drawing on the same canvas, like a ViewGroup or anything like that, won't be translated. It can do its own transformations. So let's review those steps again. We did the same thing up front. We're going to create all of our paint objects. We're going to get all of our dimensions ahead of time. Whenever we get new data, we're going to build all of our static layouts, and we're going to create our new drawable. All the hard work is done before we're actually drawing, because when we overwrite on draw, we have to keep it light. We got to keep it fast, so everything's going to be buttery smooth. We're going to draw at 60 frames a second. Another thing, item decoration is going to work really similar to this. You'll be given a canvas, and like the dividers here is how we do that. I highly recommend going to a divider item decoration. That is a default that Android provides you. Totally worth it. Dig in, look at the way that it's using a canvas, because it's a really fun example. A couple other notes on how to transform the canvas. So we talked about this. You need to move the canvas in order for your static layout to draw in the right spot. But we only did translate, but you can do a whole mess of stuff to this canvas. Basically, the way that you're actually transforming the canvas is by doing matrix calculations on it. So anything you can do to a matrix, you can do to this canvas. You can rotate it, translate it, scale, skew it. I highly recommend you play around with this. It's really fun to just mess with a canvas, draw some text on there, and then unmess with it and see what you get at the end. Again, you always have to transform your canvas back. Save and restore is the way to do this. A pro tip with save and restore, that save method actually returns an integer. So every time you call save, that number will increment. There's another restore method that you can give it one of those integers. So let's say I want to translate it, draw something, and then rotate it, draw something else, and then skew it and draw something else. I can call save before each translation and then bounce back to whichever transformation I want to undo. Yeah, so this is the example I did before. You're moving the base itself instead of the paintbrush, which is kind of the analogy here. Now, I had one more example. We don't really have time for that now. But again, I'll have a link at the end for looking at this code. This is something a little more animated. All this example is doing is that heart is a complex path object. We're going to override on touch. Again, another topic that there could be a whole talk on. But all we're going to do from that is take an x and y coordinate for where to draw this heart. And then that wiggle is done by a value animator similar to the way that we animated those bars in. In this case, we're just going to animate from -30 to 30. So we're going to bounce through all this, do those same steps. It's really important. Break it into chunks, figure out each individual component that you would need to draw, and then figure out what you actually need to define. In this case, the size of the heart and the way that we're going to animate it. So I went through this. Look at the whole project. All this is in there. It will give you some tips on how to override on touch, when to start and end your animations, when to call and validate. In this case, you want to call it only when you're drawing new stuff. For example, when the user isn't touching the screen, nothing is changing. There's no reason to invalidate your view and call on draw again because you're going to draw nothing. Same steps here. You're going to create everything up front. And then in on-draw, you're going to do as little as possible. Okay, so we don't have very long for questions, but we'll do it anyway. Slides in the Bitbucket project for this code is up here. These are some excellent talks that I would refer to for the things that we didn't cover. Dave Smith has a great talk on mastering the Android touch system. It gets really complicated once you have views and view groups. The measure, draw, layout, draw, repeat will include this stuff, but it also talks about the larger layout structure. So instead of just overriding some view and drawing some stuff in the canvas, you can also do some really powerful stuff with the way your views are laid out. Their position on screen relative to other things. You can pull basically anything off with that. Next, we talked about the Spannable talk tomorrow, totally worth your time. For the static layout and caching, I could not really find a good talk on the layouts. I got to write that talk because there's a lot to know there. But I did find this really interesting article on taking a recycler view, taking each item, drawing it in a custom canvas with that static layout. But he takes it a step farther and will actually start saving those static layouts in like an LRU cache, which is like taking that performance to the next level. He like does it before and after. He does performance monitoring and all that jazz. And it is very, very exciting. We don't have long. Any questions real fast? Okay, great. Well, I'll leave this one up so you guys can take pictures. Thank you all so much for coming.